Hello everyone, today we're going to be doing some blind simplify C++ Leetcode, and today we are working on meeting rooms 2. So, before we get started, just got to answer the 4 questions what we need. Need to ask ourselves what the input is, what data structure / algorithm / technique we need to use, what to do with the data, and what our output is going to be. So, to be able to kick things off and get things started, so, given an array of meeting times intervals, where intervals start, I, and return the minimum number of conference rooms required. So, we are given an array of interval times. We need to return a number of conference rooms required, and in this case, we're going to use a min heap, which is which is a priority queue. What to do with the data? So to be able to figure out what we will be doing with the data, we're going to break it up into 4 different steps. 1, we are going to sort the intervals by their start times. 2nd, we will initialize a min heap to keep track of all the end times of the meetings. And then 3, for each interval in the sorted list of intervals, if min heap is not empty and start time of the current interval is greater than or equal to the smallest end time root of min heap, we're going to pop the end time from min heap, and then we will add the current intervals end time to the min heap. Then we're going to output put size of the min heap. That's pretty much it. It's going to be asking just overall, based on the following times, how many meetings there are in total. The minimum number of conference rooms required. So it could be intervals, for instance, on if we have 2 meetings going on at the same time within a given context, like for instance, 5 and 10 fall in 0 and 30, or 15 and 20, we're going to need at least 2 conference rooms for the start. And in this case, we can have 1 to begin with. So let's kick things off. Now, step 1, we're going to sort. Let's begin. Intervals end. Just calling upon from the STL library, we're going to create a priority queue. Then we're going to loop through part A. If not min heap, if the min heap is not empty, and the interval at the very first index is greater than or equal to the min heap at the top. We're going to min heap. We're going to pop the heap. And then we're going to add the current element with the min heap. And then finally, we're going to output the size, so we're going to return min heap dot size. forget the comma. Alright, it passes all the test cases. Let me clean this up for you guys. There we go. Alright, and it works and passes all the test cases. So, to be able to give a rundown on the space and time complexity, the time complexity over min heap overall in solution is going to be O(n) log of n, given the fact that we are looking throughout intervals. Within our intervals array, where n represents the number of intervals, and this is also due to everything being sorted. And then we're going to have a space complexity of O of n because we are using a queue to be able to store everything. And so, yeah. That is pretty much Media Rooms 2. For the most part, it's pretty similar to Media Rooms 1. Thank you again for taking time to watch this. If you found this helpful, feel free to like and subscribe. If you have any other questions, please put them in the comment section. And as always, take care. Cheers.